Hi, this video is going to be about my troubles with doing the finger lights on the B9 robot. What I thought was going to be a little bit difficult to do ended up being extremely difficult to do. And so I thought I'd make this video to maybe help some people if they decide to go this route with their lights, because I really had a lot of problems with it, and so I thought maybe I'd show you some of the solutions I have for working these. So what I was planning on doing was having individual addressable lights in my finger lights, individually addressable LEDs. And I wanted to do that so I could have more options than just have amber flashing lights. And initially it worked pretty well. I have another video where I show you the lights working. But they didn't turn out to be very reliable. I have a lot of problems with them. Plus it was really hard for me to do for a number of reasons. So I'm going to show you what I've done, what I had done that didn't work too well, and I'm going to show you my solutions to these problems. So that's what's going to be in this video. So this is your typical setup for finger lights on the B9 robot. One thing I've done a little bit different than what most people are doing is, instead of putting glass old style incandescent light bulb, modify them and putting them on the ends, I'm actually using the belly light lens caps, and I'm cutting off the threads and basically gluing them onto the end caps. So I don't know if you can see that very well, but so I basically just cut the threads off and put those on the ends, just because I think it looks cool and it matches the belly lights. Getting the glass to fit in there and the LED to fit in there. My original LEDs, I've changed LEDs, but my original ones were kind of hard to get fitted in the glass, and so I decided to go with that. So this is essentially the type of LEDs I initially used. They're RGB and they're programmable to be able to any color you want, and each one of them can be programmed. The way they work is basically you send data in to the first chip, and it takes off the data pack and does whatever it's told to do, and then passes the rest of the data to the next chip, and it takes the first pack off of it, does it, and passes it on like that. That's the programming part of it, and those are different issues altogether on doing the programming. But anyway, I bought a sheet of these. There's 100 of them. I've used at least 30 or 20 or 30 some in trying to make these 7 lights work. So I've not been very successful at this. And the reason I haven't been very successful is this right here. It requires 6 wires. You've got a data in, a data out, power in, power out, for both positive and negative. The reason for the power in and out is just so you can chain them together easy. Problem is, these are very small, and you got to solder 6 wires on there, and I have trouble seeing out of one of my eyes, so distance up close is very hard. Depth perception is really difficult for me, so I can't really tell if I got the soldering iron on the soldering pad or the wires on the soldering pad, and I got to do this under a magnifying glass, and my hands are shaky. So soldering these are really pain for me to do. Also, I have very limited space of where I can solder them, and I'll go into that in a minute. But basically, well, I can show over here because I've taken a couple apart to show you. But I basically have to try to solder in this little space right here, and the reason is the way I wired the inside, and I'll show you that in a minute, but I can't do any soldering, or couldn't do any soldering on the inside up here, on the inside of the brain cup, because there's not a lot of room up there because of the motor housing and the shaft. You don't want the shaft rubbing up against wires in there when the motor's turning. So most of my soldering is right here. So basically, I got to clamp this in a small clamp, and I got to try to hold the wire and solder with my shaky fingers, as you can see. Very difficult to do. 9 times out of 10, I don't get a good solder. Other times, they end up shorting out once I get them in the housing. I did try on some of these. I've tried putting some hot glue around there to try to keep them from shorting out and hold the contacts. Or the contacts just basically, the solder joint comes loose. And one downside of these type of lights, if one goes out, is not passing data to the next one, then everything down the line doesn't work from that point on. So there's a real pain to do. In my first attempt to do this, I actually soldered the wires on separately. And here's an example. In this case, I only did 4 wires because I didn't think I could get 6 wires in the tubing. And so doing the 4 wires meant that the power to the next one had to be soldered on the inside instead of up by the chip. So my first problem was I used too stiff of wires. And that seems like, okay, that'd be okay for going in the tube itself, which was good. I could easily put it in a tube with stiff wires. But inside the brain cup, they were too stiff by the time you got all those wires. And remember, you got these 4, the 4 coming from here, soldering wire that goes from here to here for the power and here to here for the power, and so on and so forth. So once all that's soldered up and the shrink wrap is on there to keep them shorting out, they were too stiff. And what would happen is when one light would move, it would pull up the other light, and you would get a mess. Nothing would work individually. So I had to change the wire. So that's the first thing you want to do if you're going to do this, is make sure you're getting extremely flexible stranded wire. You want stranded wire because solid core wire is not very flexible. So you want stranded wire. And the best thing to get is silicone insulation. Silicone insulation is very flexible. And basically it's so flexible that when I tried to solder on here, the wires would keep bending out of the way. That's how flexible they are, whereas these stiffer wires are a little easier to solder. But anyway, use silicone-based insulation and get the most flexible wire you can. That makes a huge difference. Now, that being said, again, I soldered the wires here, then I put the wires up through the tubing, and then I would do solder connections up in here, put shrink wrap on it, and then glue them to the inside of the brain cup so that the wires wouldn't be touching up against having a chance of touching the motor shaft up inside. Problem with all that is there's not a whole lot of room inside the brain cup. Oops, sorry, didn't mean to bump the camera on you. Just trying to get a better angle. There's not much room up in here, and what happened was basically I could not get the brain cup, the inner part of the brain cup. And if you remember, we've got a motor mount here that takes up a good part of the inside. So you got very little room there, and I couldn't clear the wiring to put the motor mount in. So that didn't work out too well. So that's when I went to the silicone wire, which is more flexible, pulled all this out, and made a continuous loop, more like these are supposed to work. In other words, you should solder the, solder the input, and then have wires going out, and then they would come, 3 wires would come in from here, go solder to the LED, the outs go from the LED back down the tube and over to the next one. So this part of the wire is one continuous wire, and there's 3 wires going from this one over and into that. That's why this ends up being hard to solder, because you got such tight quarters there to do that. but it makes for fewer solder joints, much more reliable back on this end, and it really cleans up the area back in here. So before I go any further, I'm going to show you the inside here of what my solution was in doing this setup here. So pardon my shaky hands and moving things around, but here's the inside of my brain lights, finger lights now. And as you can see, these very flexible wires allow me to make quick bends right from one end to the other. And so you can see 3 wires that go up in here, then they come out and they go back into the next one. And all of that results in having very flexible movement there, very free movement. And very little wires are sticking out once I get them in place. Now I've moved the wire